Okay, hi guys, so we'll be continuing on seeing more on enthalpy. So let's get started. So we have H equals to, let's say it's a function of temperature and pressure. So now we can write dH as del H upon del T at constant pressure time dt plus del H upon del P at constant temperature times dH. Okay, and for an ideal gas, we know that enthalpy is just a function of temperature only. So we can write that del H upon del P at constant temperature is 0. So from the above equation we can write dH would be equals to, this is dP rather. Okay, so dH would be equals to, as this term is 0, so dH would be equals to del H upon del T at constant pressure times dt. And what is del H upon del T at constant pressure? So suppose we have Qp, which would be equals to Cp dt. Okay, and Qp at constant rather Qp at constant pressure would be equals to dH. So dH upon dt at constant pressure can be written as Cp. So I can write this term as dH would be equals to Cp dt. Okay, so for n moles of an ideal gas, we can write that for n moles of an ideal gas, we can write that dH would be equals to n cpm dt. Okay, so this is always applicable for an ideal gas, and for ideal gas we also know that PV equals to nRT. Oops. Okay, so and we also know that dH equals to du plus dPV. So instead of dPV we can write dH would be equals to du plus d of nRT. Okay, so from this let's take some cases when what happens for an ideal gas compression expansion rather. For ideal gas compression expansion, we will have, let's suppose, n as constant, then we can write dH would be equals to du plus nr dt, just opening up that differential form of d of nRT. So from here we can write delta H would be equals to delta u plus nr delta t. Okay, and we know that delta u can be written as, for an ideal gas we can write delta us n cvm delta t plus nr delta t. So from here we can take out delta t and n as common, so we can write n cvm plus r delta t. So we know that r plus cvm is equals to cpm, so we can write delta H for an ideal gas would be n cpm delta t. Okay, now let's see what happens in case for chemical reactions or phase transformations. We can have, let's say we have constant temperature So at constant temperature we can write dH would be equals to du plus, let's say, RTDN, where we have constant temperature and number of moles are changing during the course of the reaction. So here we can write delta H would be equals to delta U plus delta Ng RT. So delta Ng here would be number of moles of gaseous products minus number of moles of gaseous reactants. So delta Ng here would be, delta Ng here would be number of moles of gaseous products minus number of moles of gaseous reactants. Number of moles gaseous reactants. Okay, this is important formula. Okay, so for an example, let's take the reaction of H2G with O2G forming H2OL. Okay, so in this reaction delta Ng for this reaction would be minus 3/2 because 0, which is the number of moles of gaseous products, minus number of moles of gaseous reactants would be 1 plus half, so that is minus 3/2. In case of, let's say, COCO3 solid dissociating into CaO solid plus CO2 in gaseous form, so delta Ng for this case would be 1. Number of moles of gaseous reactants would be, or rather gaseous products would be 1 here, and there is no gaseous reactant or product other than CO2G. Next we can also have H2G reacting with I2G forming 2 moles of HIG. Okay, so for this also delta Ng would be minus 1, or rather 0, because number of moles of gaseous products formed is 2 and number of moles of gaseous reactants would be again 2, so delta Ng would be 0. So in this case we can write delta H would be equals to delta U. Okay, now let's see what happens in case of these reactions. So we have XS converting into XG, so here delta Ng would be plus 1, XL converting into XG, delta Ng here would be again 1, and delta G converting into delta rather XG converting into XS, so delta Ng here would be minus 1. So this says that at least one phase should be in gaseous phase. Okay, so with this we come to the end of this lecture. In the next lecture we'll be seeing standard states. So till then, good luck and goodbye.